Yep, thank you. So this presentation is really derivative of a paper we have in revision right now in Fish and Fisheries. So I acknowledge my co-author team here representing a number of Great Lakes folks, as well as colleagues from Alaska and Norway who helped out with this one. And I also really want to acknowledge all of the different colleagues around the basin that really humored us and helped us dig out all of the available historic records and data, or even just recent anecdotal observations on pink salmon. So, for those who are from the Great Lakes, you may be thinking, why did we put in all of this effort to dig up information on pink salmon? So, to explain that, I thought I'd structure this talk in the same way I learned about pink salmon. Prior to joining NOAA, I was a postdoc for the University of Alaska working on the ocean ecology of Pacific salmon in their native Pacific, where pink salmon are viewed in a very, very different light. So, first, I want to kind of introduce this species as they exist in their native range. As we'll get to, they're breaking some rules here in the Great Lakes. They're the most widely distributed and smallest of the Pacific salmon species. On the North American side, their spawning distribution roughly extends from Washington state up to the Arctic coast of Alaska. In general, depending on the population, they spawn from summer to early fall, usually not far upstream. The species is not picky about where it spawns. They'll even spawn in the intertidal. When those fry emerge in spring, they migrate to sea immediately. They do not use streams as nursery habitats, allowing them to spawn in more places. They'll enter the ocean at about 35 millimeters, so very, very small. In the ocean, they have a very flexible diet, taking advantage of kind of whatever they run across, typically any zooplankton, and as they get larger, fish and squid, which fuels very rapid growth. They have to grow so quickly because their life cycle is very short. In the Pacific, almost without exception, they mature at 2 years old. So eggs that were spawned this past fall, 2025, will grow to pink salmon. They will all spawn in 2027 and die. Even though they have a very short life cycle, they travel great distances. Estimates in the Pacific suggest that during the pelagic stage, they'll cover 4,000 to 5,000 or more kilometers. Then, when they come back to spawn, they have a really high straying rate. More so than other Pacific salmon, they will spawn in streams different from where they themselves spawned. So putting this all together, they are not picky about their spawning habitat. They don't need streams as nursery habitats. They have a flexible diet. They travel greatly and tend to wander from where they were born. They're an excellent colonizer. And this excellent colonizer is currently causing management problems in 3 separate oceans. In the North Pacific, they've recently surged to absolute record abundance. So this figure on the right shows in pink is pink salmon abundance numerically estimated for the North Pacific at large. Blue is pink salmon harvest. This black line is combined harvest of all of the other Pacific salmon. Pink salmon are numerically absolutely dominant in the North Pacific right now. Harvests basin-wide have exceeded 600,000 metric tons in recent years. Now, as they have surged in abundance, they've also expanded their range. They're one of the Pacific salmon species extending into the Arctic, raising substantial concerns, especially among Arctic indigenous peoples, about the effects of this species on sensitive Arctic ecosystems should they colonize. But in that Pacific range, they're causing large-scale trophic cascades through their intense predation on zooplankton and small fish and squid. Due to these really high abundances, there's now emerging evidence that they are decreasing the growth and survival of other mid-trophic level forage fishes, as well as higher trophic level predatory fishes, including their fellow Pacific salmon, notably Chinook, coho, and steelhead, like we have here in the Great Lakes. So for our third ocean, they're also causing problems in the North Atlantic right now. Pink salmon were introduced by the former Soviet Union, now then Russia, into the White Sea area. So that is the part of Russia right next to the very northern extent of Norway. They were introduced from the 1950s to the 1990s, and they were able to achieve limited natural reproduction, such that when they stopped stocking in 1999, for the subsequent years through the 2000s, they had low-level returns. Pink salmon were returning, they were sustaining themselves, but there was no real population trend and abundance was very low, so it wasn't a substantial concern. That changed in the mid-2010s. Exponential growth began. We're not fully sure why. We think this is due to rising ocean temperatures for this extreme northern habitat. But what happened is between 2017 and 2023, observed numbers of pink salmon increased across Nordic nations by a factor of 50. So streams in northern Norway went from having a few thousand pink salmon to nearly 250,000 pink salmon in just 6 years or 3 generations. Now, pink salmon are also spreading across the North Atlantic. So you can see in this figure, this 2017 map at the top, 2023 at the bottom. Hot, larger colored dots are high abundances. This high abundance area is marching down the coast of Norway, but they're also dispersing very far. Pink salmon are now closing the life cycle in Scotland, closing their life cycle in Iceland. They're being caught throughout Greenland, and then throughout Atlantic Canada, as far from their source as Newfoundland. So from the ocean, we can say that pink salmon are an excellent colonizer, capable of explosive population growth when conditions are right. Abundant pink salmon cause trophic cascades and disrupt food webs across large spatial scales. So it's really important to monitor and manage this species wherever they occur, and it's particularly a high priority to understand in a given area what regulates their productivity, what is allowing for large population increases, what is behind population decreases. So that brings us to the Great Lakes. Yes, we do have pink salmon here, though some folks are still not aware of that. There are only introduced salmonid that got here by accident. So in the 1950s, Ontario was trying to introduce pink and chum salmon to Hudson and James Bays. They needed nearby hatchery infrastructure to do so. So they gathered pink salmon eggs from northern British Columbia from the Skeena River system and brought them to a hatchery on Thunder Bay in northern Lake Superior. They spilled a few pink salmon when they were loading float planes. Some got mixed with lake trout, but the largest introduction came when they were sending the last plane to Hudson Bay. They couldn't fit the final 21,000 pink salmon fingerlings on that plane. The hatchery staff dumped them into the sewer. That sewer went right to the Current River next to the hatchery, a tributary to Lake Superior. So that introduction was about 21,000 to 21,500 fingerlings. If we assume they survived at what would be a typical North Pacific rate, that would have resulted in about 600 spawners in that first generation that would have spread across a number of streams. So this is an extremely small introduction, also unique from one source population, from one single brood year. But that population did take. Fishermen started turning in these weird-looking salmon in 1959 from Minnesota streams. They were identified as pink salmon. From there, this population kind of spread out following that Atlantic pattern, where there's this core area slowly spreading, but there was occasional longer range dispersal to other parts of Lake Superior. They then broke out of Lake Superior and colonized the other Great Lakes. Lake Huron in 1969, Lake Michigan in 1973, and then Lakes Ontario and Erie in 1979. So in the Great Lakes, their ecology is in some ways very similar to the Pacific and really mirroring what was true of that source British Columbian population, and in other ways has diverged. Their fry emerge in mid-April to May and immediately outmigrate to the lake, again at around 35 millimeters. So these are very, very small smolts, I guess you could call them, exiting to the lake. We have very little information about their distribution in lake habitats. They're almost only caught as they're coming back to spawn. But the data we do have and what we know from the Pacific suggests they have a largely pelagic distribution. And growth data we have suggests that they are not moving between lakes, not even between Lakes Michigan and Huron with large frequency, as pink salmon are quite different sizes across lakes. And so we're seeing evidence they're feeding on different food webs. Their diet is, if you take the analogs of what they feed on in the Pacifics and map it onto the Great Lakes, more or less what you'd expect. A bunch of different zooplankton, terrestrial insects, and then as they get larger, they'll feed on fish, particularly rainbow smelt and alewife. Now, one of these major divergences, where I said almost every pink salmon in the North Pacific matures at age 2, only a couple of observations have ever been found of non-age 2 spawners. Pink salmon in the Great Lakes have been observed maturing at ages 1 to 4, still largely at age 2, but age 3 is not uncommon. 1 and 4 seem to be more rare. Their spawning is from September to mid-October. They tend to spawn a bit earlier than most of the other anadromous salmonids in the Great Lakes. But interestingly, they've been observed beach spawning along lake shorelines, suggesting that there may be more spawning habitat available to them here than we thought. They've also been observed occasionally hybridizing with Chinook salmon. We don't yet know if those offspring are viable, though the guess is probably not. They're probably sterile. So for this work, we tried to dig out all the available information we could to assess what has the population trend been over time. They really increased through the 60s into the 70s, and the populations across the basin really reached their peak in the late 70s to mid 80s with kind of different peak timings depending upon the lake. Then they entered a decline in the 80s and 90s that really seemed to coincide with high abundances and high stocking rates of other salmonines, as well as declines in forage fish abundances. So we think that competition probably played a role there. They didn't stay down for that long, though. They began increasing again in 2000 or so. You can see that in two of these figures. These are catch per unit effort levels from creel surveys throughout the Great Lakes. So on the main diagonal here, this is northwestern Superior Minnesota waters and Michigan waters of Lake Huron. You can see that while there's a huge variability here, largely driven by, again, most of these fish spawning at age 2, so you have some kind of year class effect going on, there is an increasing trend over time. It is statistically significant in both Lake Superior and Lake Huron. I'd also note that the increase in Lake Huron began immediately following the Dresinid invasion. So when a lot of other mid-trophic level fish declined, pink salmon started increasing, which raises interesting questions about what they're doing there. For Lake Michigan, though, given that this is the Lake Michigan section, I want to point out they were in very low abundance to absent from angler catches for a long period of time. And in recent years, we're seeing year classes about an order of magnitude, at least in terms of catch per unit effort, larger than anything we've observed in decades. And that's the same in Michigan waters of Lake Superior as well. As we talked to the folks from all of those agencies throughout the Great Lakes, what we consistently heard, whether they had data or not, is anglers are telling us they're seeing a lot more pink salmon all of a sudden in the last few years, and they're seeing them in more places. So we have evidence that something is allowing recent large year classes to occur, and pink salmon are either colonizing new spawning streams or recolonizing spawning streams that had been abandoned as their abundance waned over time. So looking forward, pink salmon have certainly played a minor role in the Great Lakes fish community for most of their invasion history, with the exception maybe of the late 70s rather to early 80s when they were quite abundant. However, they're biologically capable of very rapid increases in abundance if conditions become advantageous. So the concern here is, if they were to become abundant, could they restrict growth and survival of other fish through competition and predation? It's a little harder to answer that question in the Great Lakes because they are exhibiting these unexpected behaviors and adaptations. Changing their life cycle really changes their population dynamics, as an example. We also have very little knowledge about what is regulating their productivity here. And so that makes it very difficult to predict future trends. So in our paper, we tried to outline some top research priorities. I also included some other things here that I think would be useful context. First, we really need to have a better understanding of where, when, and how large pink salmon runs are throughout the Great Lakes. Where are they spawning? Where are the largest runs? Are they changing in time across the different areas of the basin? How is that correlated to temperature? All of those kinds of things. We also need to now have a better sense of what species pink salmon may compete with throughout their life cycle. Pink salmon are included in a number of the recent predator diet studies, but again, pink salmon are almost only caught as they're approaching spawning. They're exiting streams at 35 millimeters feeding on plankton. So we don't have a good sense of throughout that whole growth, throughout that whole life cycle, what species may they be competing with for prey. And then obviously, what factors influence population productivity? What is behind these recent surges, whether it's that noisy but kind of steady increase in Lakes Huron and Superior, or in some areas where we're seeing recent giant year classes seemingly out of nowhere. But I think it's also important to contextualize this information with more knowledge about their pelagic habitat use, the relative frequencies of maturing across different ages, and what consequences does that have for productivity, as in, if they delay maturation, could that influence their fecundity in some important way? And then also, what is the true cause of growth differences across lakes? Is it purely relative productivity of the lakes? Does temperature play a role? And how do those two kind of combine? So that's all I have. And with that, I'm happy to answer any questions.